Hello, my name is Ryan, and this is my Thermoacoustic Refrigerator, a device that uses sound to produce a temperature gradient. I built this back in 2006 as part of my senior design project at the University of Portland. Thermoacoustic refrigerators have many real-world applications, and one of these is as cooling equipment on satellites or other spacecraft. They have a few attributes that make them particularly well suited for cooling equipment on spacecraft, including the fact that they can be made quite small, and this one is actually quite large. And another attribute is that they have few moving parts, which makes them extremely reliable. The device has a number of components, about 5 components, the first of which is the resonator tube here. And the resonator tube can be made of a number of different materials. In this case, it's made of Schedule 80 steel pipe. The second component is called the pressure wave generator, and it's housed inside this end of the device. The pressure wave generator is actually just a loudspeaker that's driven by a function generator producing a pure sinusoidal wave. As that speaker vibrates back and forth, it produces a sound wave that propagates down the tube. The third component is what's called a stack. And the stack I have here is actually made of the substrate from a catalytic converter, but it can be made of a number of things as well. You may be able to see that there's hundreds of small holes that penetrate all the way through the length of the stack. And these small holes create a large surface area for the fluid inside the device, the gas, to thermally interact with. The stack sits inside the tube, right about this location. Now, the fourth and fifth components of the device are heat exchangers that would be placed on either end of the stack inside the tube. So how does the device work? Well, as I said before, the pressure wave generator moves back and forth and produces a sound wave that travels down the tube. As it ricochets off the far end of the tube, it returns and interferes with oncoming sound waves. If you do this at just the right natural frequency of the tube, it actually creates an interference pattern called a standing wave. And standing wave basically is just a node and antinode that are at fixed positions inside the tube. So, without going into the heady mathematics of how this produces a temperature gradient, I'll give you a simple demonstration of how it would work. The pressure wave generator would withdraw in one stroke, and in doing so, packets of gas at this end of the stack would be pulled towards the pressure wave generator. As they expand, and when they expand, they cool, and they become cooler than this end of the stack. In doing so, they draw energy from the thermal energy from the substrate material at this end of the stack. Then the pressure wave generator plunges forward, causing the gas packets to displace down the length of the stack, where they become hot and compressed. They become hotter than the substrate material at this end of the stack. And in doing so, they thermally exchange their heat and release the heat down here. Now, you can imagine if this is done hundreds of times per second, you actually create a thermal gradient where one side of the stack becomes hot and the other side becomes cool. If you have a heat exchanger on either side, you can exploit this temperature difference as a refrigeration effect. Now, unfortunately, the device is not operative right now. I don't have the equipment with me to demonstrate its performance. However, I might save that for a future video. What I can say is that at the time of my senior design project, we were able to achieve a 10-degree Rankine or Fahrenheit temperature difference across the stack. And while that may not sound like a lot, and it certainly isn't, we definitely demonstrated the thermoacoustic refrigeration effect very effectively. Given fewer time constraints and budget restrictions, I'm sure that future improvements that I intend to make on the device can capitalize on some of the insufficiencies of the device that we found during construction. And I may well make those improvements and demonstrate them at a future date. If you have any questions about my device or any comments, please feel free to email me at my email address below. And I hope you have enjoyed my video, and thanks for watching.